A long time ago, there were 4 tribes living a peaceful life due to a treaty made by our ancestors, namely the Chronos, Fervor, Astral, and Rigor tribes. My tribe, the Chronos, dominated the 4 tribes at that time. As for they are known to have enhanced their technology and developed their abilities to a maximum concerning time. Fervor tribe, they are all about kindness and harmony, always happy. The skillful ones, the ones who value discipline and preciseness, they are in Astral tribe. They keep everything in order. And then there is Rigor. They are the protectors, our soldiers, our police, strong and fearless. The Time tribe, also called Chronos, the others define them. They have a blank persona yet known for their intelligence, for making inventions and discoveries. Everything was at peace for these 4 tribes, even though they have their own principles and beliefs. None pushed their thoughts as to be someone supreme, until one day an unexpected tribulation came upon them. A war broke against each tribe, and everyone within reach hears an ear-piercing scream which comes out from different sides, speaking out their distaste for the current situation and government. Each and everyone seeking and yearning for the power of the other tribe. A never-ending cycle of war came upon them. In a few weeks' time, it caused a black hole to form on the center of the war, causing everyone to be absorbed within. A few made it out and survived, realizing how their power can change everything. They had vowed to never speak of this event again. Everything concerning the past and their powers has been erased in their minds and tried to live a normal life.
Sino ka? Ano ba gusto mo?
Tutunga ka na lang ba dyan? Tinan mo nga yung sarili mo? Puro lalaki mga...
Welcome to my life. Living the past 18 years has been a tiresome cycle. I go to school, I walk past this ordered hallway filled with unruly students and alligated professors. I encounter dilemmas. Just like that one. And that one too. You see, my life is like a circle. I see no point or end, but at least I have my reason to get up from bed every morning.
Ano ba? Galing sa library yan.
Ano ba yan, Leia? Itong kinukuha mo sa library na libro, parang may namang pinagkaiba sa kahapon. Bakit ka ba nagsasawat? Ulit-ulit na yung mga pinabasa mo. Ano kaya kung tungkol sa pagpapalaki ng mga dimensions na pinapalakas ng mga wormholes? O kaya pagpapalakas ng kapangyarihan?
Ano ba? Di ba, napag-usapan na natin to? Hindi natin to dapat pinag-uusapan sa classroom o kaya sa public.
Dali ako. Relax ka lang. Masyado pang maaga para magalit kita.
Ay nako, bagsak na naman. Dali-dali lang eh.
Hindi mo kasi malansin. Wala akong sumunod ngayon.
Bakit? Ang gagawin mo, lalabang ka ba? Lalabang ka ba?
Gusto ko talaga ng away, no?
Would you mind explaining what happened between you two earlier?
Guys, this is not the first time na nangyari sa atin ito. And we can let this happen again. Alam niyo naman na hindi natin pwede i-expose yung powers natin sa labas, di ba? Paano na lang kung may nakakita sa atin?
And we can let that happen. Now, I need to go back and fix everything you've ruined.
Ito kasi, hindi mo sana ako sinubukang patayin. Hindi sana wala tayo dito ngayon. Budget ulit tayo kay boss.
Ano nga ko? Kung di mo sana pinairan niya kayabangan mo, edi sana nasa klase tayo ngayon.
Yan. Tigilan nyo nga yan. Magsisimula na naman kayo. Ang laki-laki nyo na, oh. Sil, tumigil ka na. Tigilan mo yung pagiging isip bata mo, ha. Ikaw naman, Lawrence, siya mo na to. Alam mo na yung utak na ito, di ba? What if there's not around? Makayos niya ba itong gulong to?
Oh, guys, dating pwesto. Natural lang, ah.
Tama na to.
Inaantok na.
Settle down. Miss, will you please turn off the light? Thank you. Siya tayo natapos? Saan history? Ito? Ayan. To continue our topic about the theory of relativity, which involves the space, time, gravity, and spin, I would like to tell you all a very old tale. It was said that the population were divided into 4 to keep the peace, and each tribe have a specific power they possess. The first one, the Astral tribe. They possess the power of space. They make wars and manipulate them. Second one is the Chronos. They hold the power of time together with motion. They can stop it whenever they want to or if they need to. The third one is the Rigor tribe. The power of gravity is in their hands. They make the ground moves just with their palms. And lastly, the Fervor tribe. They possesses the power of the speed, and they travel places in the nick of time. Right, Mr. Kristen? Okay, but what I told you guys is just an old tale. So hindi nyo naman kailangan maniwala. Okay.
Ay, botra na yun.
So, in reaction to that, I would like to show you a very short video regarding our topic. Please write down notes. Meron kayong reaction paper na kailangan ipasa mamaya. Stand up!
May cheering pa kami.
No more bats!
Oh no.
Did you know that you could be older than your twin? Like years older? According to Einstein's theory of special relativity, it's possible because time can tick faster or slower depending on how you're moving. What? Yeah, we'll get back to that. But first we're gonna learn all of special relativity. Don't worry, there are only two postulates. One is that the laws of physics are the same for everyone's perspective, or frame of reference, while in uniform motion. So that means that on a plane cruising at 800 kilometers per hour, an object you drop will fall straight down, just as it would if you're stationary on the runway. Same physics in those two frames, otherwise plane rides would get real weird. The crazy implication of this postulate is that there's no experiment you could do to tell that you're moving, even at 800 kilometers per hour, even at 1,000,000 kilometers per hour, because you can only tell you're moving relative to something else, like the clouds outside your window. The second postulate is that the vacuum speed of light is the same for all observers, 300,000 kilometers per second. Let's just pause on that for a sec. Do you know how freaky this is? It means that if you're flying toward me in a spaceship going close to the speed of light and you shine a laser at me, you'll still measure that light to be going at 300,000 kilometers per second. And I'll measure the light to be going at 300,000 kilometers per second as well. So those are the only two postulates of special relativity. The speed of light is a constant, and the laws of physics are the same in every inertial reference frame. Inertial meaning not moving or moving at a constant velocity. Basically, you're not accelerating. And when you do accelerate, like when you experience turbulence or during takeoff when you're pushed back into your seat, you can tell you're moving and special relativity no longer applies. So it's from just these two postulates that we derive an entire physical theory and get crazy things like length contraction and time dilation and other weird quirks of physics that are real. One such quirk is that time can tick at different rates depending on how you're moving. We call this time dilation. It's weird, but it's real. Why does it happen? Consider two frames. One is you stationary on Earth, and one is your twin zooming by in a rocket. You have identical clocks. Let's look at yours first. Each time light makes a round trip in your clock, you count by 1. Your twin will measure the same rate on her own clock. Now, things get weird when you watch her clock. Because of her sideways motion, you see that her light has to travel a longer distance for one tick. And since the speed of light is the same for all observers, her round trip ticks must take more time. So time actually ticks slower on her moving rocket according to you, stationary on Earth. And this is a real phenomenon. It's not some weird mind trick. We don't usually notice this though, because time dilation is quite insignificant until you're moving close to the speed of light. So now, from your twin's perspective, you are moving. Therefore, your clock must be running slower according to your twin. And because the laws of physics are the same in both of these frames, yours and hers, each frame is equally correct in saying the other's clock is running slower. This is where the paradox starts. Imagine you and your twin start off on Earth. You stay here, but your twin zooms off in a spaceship at half the speed of light, turns around, and comes back. The whole trip takes 30 years, but you see your twin's clock tick slower. So, due to time dilation during the journey, she only aged 26 years, 4 years less than you. Now, here's the crux of the problem. From your twin's perspective, she was stationary, and you, on Earth, moved away and came back. You're the one moving at half the speed of light. So your twin should see your clock going slower and should think you are only 26 years older by the end of the trip. So yeah, that's not possible. When your twin gets back, she's either younger or she's older. She can't be in a superposition of both. This isn't quantum. So how do we solve this paradox? Well, the answer lies in the details. When your twin turns around, she has to accelerate, which means she's no longer in an inertial reference frame while she accelerates, and so special relativity no longer applies to her. It's not as simple as saying your twin sees you make a round trip and you see your twin make a round trip. It's not a symmetric problem like that, because when your twin accelerates, we can tell the difference between the physics that might happen in those two frames. She will feel the acceleration during the turnaround, and you will not. So when she gets back, she will agree with you that you are 30 and she is 26. One last question. What's happening to the clocks during the period of acceleration? We still get time dilation, but we have to use a different set of rules from general relativity. General relativity states that clocks run slower in accelerated reference frames. So while your twin is turning around, her clock runs slower. And she sees the same thing. She sees your clock running faster than hers, so you're aging quicker. It's during this period of acceleration that you become the older twin. Now, this phenomenon of time dilation in an accelerated reference frame is related to time dilation in a gravitational field. General relativity says that clocks run slower in gravitational fields, as you may have seen occur in the movie Interstellar. You can get time dilation and other strange things occurring during different forms of motion. Special relativity and the twin paradox are just the tip of the iceberg.
The setup for the twins paradox is as follows. Suppose I sit on Earth while you head off on a rocket ship at a constant speed for a while, then turn around and come back. We know that moving things experience time more slowly, so I'll think that when you get back, you should be younger than me. But from your perspective, the Earth with me on it is doing the moving, receding and then returning, so you think that I should be younger than you. Who's right? We'll use the fact that time rotates to sort this all out. Okay, so from my perspective, every second that passes, I stay in the same place, while every second that passes, you get farther away, and then closer. Simple enough. From my perspective, you'll take 10 seconds to get back. And since you're moving, I'll think that time is passing more slowly for you, so I'll calculate that your journey, for you, takes 8 seconds. Now, and this is the important bit, since you're moving, what you think of as the forward direction of time will be rotated relative to my perception of time. So on your outward journey, the seconds will tick away like this, and on your return journey, the seconds will look like this. From your perspective, your journey does indeed take 8 seconds. But almost immediately, we also see the solution to the twins paradox, right here. This bit of my time is unaccounted for by you. During your entire journey, you'll think that time is passing more slowly for me than for you. And indeed it is. Here and here add up to only 6.4 seconds. But because of your change in velocity when you turn around to come home, your notion of time rotates and skips right over a large swath of my time, which amounts to precisely, you guessed it, the missing 3.6 seconds. And this is the resolution to the twins paradox. Because you changed velocity, your notion of simultaneous times rotates, so your accounting of how time passes in parts of the universe far away from you will have gaps in it. Well, in reality it wouldn't have gaps because you couldn't instantaneously change direction. You'd have to fire your rockets to start heading home, and during that acceleration, your notion of time would have very, very quickly rotated through the missing gap in my journey, allowing you to properly account for the missing time. In summary, during your outward and return journeys, 10 seconds would pass for me, and I'd calculate 8 seconds as passing for you. 8 seconds would pass for you, and you'd calculate 6.4 seconds as passing for me during your outward and return journeys, and 3.6 seconds as passing for me during your acceleration, even if it was basically instantaneous. So we both agree that when you come home, you'll be younger. And indeed, this is exactly what happens when you send an atomic clock flying around in an airplane. It records less time as having passed than a twin atomic clock that stays on the ground. P.S. The time rotations I've been talking about are actually called Lorentz transformations, and they're the way that most working physicists think about special relativity and things like time dilation, relativistic Doppler shifts, and so on. Trying to understand relativity just by using basic equations for time dilation and length contraction, like is often done in beginning physics classes, will often lead to confusing apparent contradictions, because these equations don't take into account the full changing of simultaneity of events, and so on. Hey, Henry here, thanks for watching. I'd like to thank The Great Courses Plus for supporting this video. The Great Courses Plus is a video learning service with thousands of lectures and courses from university professors, Smithsonian curators, National Geographic photographers, professional chefs, and so on. They even have courses by some past guest narrators of Minute Physics, Sean Carroll and Neil deGrasse Tyson. The Great Courses Plus is offering a free 1-month trial at thegreatcoursesplus.com/minutephysics. Again, that's thegreatcoursesplus.com/minutephysics, or follow the link in the video description.
That would be all. You may now start your reaction phase.
모르네 calling 헤어나올 수 없어 제발 homie 내 인연의 끈이 넌지 기다린 네가 맞는지
Ganyan mo muna. Yan. Guys, camera action!
Layo, wala.
Ulit! Ulit! Oo! Cut!
Nice try.
Johnny!
Perfect yung pagkagalaw.
Imilag eh. Huwag kang
Kitin ko.
Tapilok!
You are so beautiful
Ano dito? Di ba kunyari? Sa harap.
You are so beautiful
Uy, galing sa libro yan.
ay di na dapat
Dahan-dahan lang kasi.
Ano? Tutunga ka na lang ba dyan? Tingnan mo nga yung sarili mo. Puro lalaki yung mga...
Oh, wag kang! Wag kang!
Yung bibig mo.
Wag kang!
Wait lang.
Sa piling mo ay nalulula. Unti-unti rin.
Game!
look wonderful
Ito kasi hindi mo sana ako sinubukan patayin, di sana wala tayo dito ngayon. Please mode.
Anong ako?
Hindi pa tapos yun.
Ba't please?
Sinubukan patayin, di sana wala tayo dito ngayon. Bakit tuloy tayo kay Bro?
Anong ako? Hindi mo sana pinairal yung kayabangan mo. Sana, mapalala tayo ngayon.
Kasi yung tricycle eh.
Ulit.
Pakain mo kay Kiboy ang ice log. Ay, gusto mo, now we need to go back and fix everything you do. And no.
Tignan mo huli.
Now we need to go back and fix everything you ruined. Ulit tayo ulit. From the start. Would you mind?
Would you mind explaining?
1, 2, 3.